Good morning, my dear children. Today, our learning objectives to learn about what are the factors affecting the reaction rate. The page number 222. What are the factors affecting the reaction rate? Before learning this topic, already we discussed some area. Our lesson is unit number 7, chemical kinetics. Reaction, the rate of the reaction, rate of the chemical reaction, and about the stoichiometric and the rate of the reaction. What are the average and instantaneous rate? And about the rate law and rate constant, one of the very important question, rate law and rate constant, differences between rate and rate constant of the reaction molecularity. And one of the 3-mark question, very important, about the differences between order and molecularity of the reactions. The integrated rate equation, the integrated rate law for a first order reaction, one of the very important 5-mark question. Pseudo first order reaction, integrated rate law for a zero order first order reaction. Examples of zero order reaction, one of the very important 2-mark question. Half-life period of the reaction, one of the 3-mark questions, a very, very important question. And about the collision theory, Arrhenius equation, the effect of temperature on the reaction rate. It's a very, very important question for the 5-mark question, Arrhenius equation. After that, last topic is about that, what are the factors affecting the rate of the reaction, otherwise the factors affecting the reaction rate. Sometimes the question may be asked in 2-mark. What are the factors affecting the reaction rate? It may be 5 types. One is about that nature and state of the reactant. Number 1, nature and state of the reactant. Number 2, concentration of the reactant. Number 3, surface area of the reactant. Number 4, temperature of the reaction. Number 5, presence of the catalyst. These are the 5 factors affecting the reaction rate. Here we can be discuss first one, the nature and the state of the reactant. Number 2, the concentration of the reactant. Number 3, surface area, that is the effect of surface area of the reactant. Number 4, we can be discuss about the presence of catalyst. Okay, the first one is about that nature and state of the reactant. Here we know that a chemical reaction involves breaking of certain extending bonds of the reactant. Some of the breaking of bonds are breaking and forming a new bonds, and we get a products. Here, the net energy involved in this process is independent on the nature of the reactant. The net energy involved in the process is dependent on the nature of the reactants. So anyway, the rates are different for different reactants. The rates are different. Rates are not the same. They are different for different reactants. We can be discussed one by one here. About one of the redox reaction. What is about the redox reaction means? Oxidation reduction reactions are called as redox reactions. That means a reaction, one of the reactant undergoes oxidation and another one undergoes reduction. Here the day life examples. What are the examples means? Some of the redox reaction includes about the photosynthesis, respiration, combustion, corrosion. These are all examples of redox reaction. In our chemistry, one of the very good examples about the redox reactions are one of the titration between ferrous ammonium sulfate and potassium permanganate. one of the titration between ferrous ammonium sulfate. Ferrous ammonium sulfate, simply we can be say FAS, ferrous ammonium sulfate with the potassium permanganate, that is KMnO4. Another one, redox reactions, that is a reaction between oxalic acid and potassium permanganate. Oxalic acid means COOH, oxalic acid, and potassium permanganate, KMnO4. Here, first redox reactions and the second redox reaction have some difference. Here, what is the differences means? The first one is about that potassium permanganate versus ferrous ammonium sulfate. Second one is about an oxalic acid with the KMnO4. For the oxidation of oxalate ion, that is oxalic acid gets from the oxalate ion by KMnO4, in the reaction is very slow as we are comparing the reaction between potassium permanganate and ferrous sulfate, otherwise ferrous ammonium sulfate. Here, oxidation of oxalate ion here by KMnO4 reaction is very slow, because what is the reason means, in this reaction heat is very, very important. About 60 degrees Celsius is applied for this reaction, that is oxalic acid versus KMnO4. Here, about the physical state of the reactions also play an important role. Here, what is an important role means, the gas phase reactions are faster as we are comparing to the reaction involving solid or liquid reactant. Gas phase reaction is very, very faster as we are comparing to the solid or liquid reaction. For example, sodium metals with iodine vapor. This reaction is very fast as we are comparing the reaction between solid sodium with solid iodine. Here, what is the reason means, iodine is a vapor for the first reaction. First we are taking sodium metal with iodine vapor. Next reaction is sodium metal with iodine solid. Here, as we are both of them are undergoing reacting. Anyhow, first reaction, that is a sodium metal with iodine vapor, is faster than the reaction between sodium metal with solid iodine. This is one of the physical state of the reactant. Next, we are considering the another one examples about that potassium iodide with lead nitrate. We are taking in aqueous solution, and whereas another one is about the solid solution. In aqueous solution, here we are taking a colorless potassium iodide with a colorless solution of lead nitrate. Both two solutions are colorless solution. Which are the two solutions? One is about that potassium iodide solution. Another one is about that lead nitrate solution. Potassium iodide is also colorless. Lead nitrate is also colorless solution. This two solution undergoes reacting. Both of them are reacting. We get an yellow precipitation of lead iodide. Lead iodide. Here, another one we are taking, we are taking solid lead nitrate with the solid potassium iodide. Here also we get one of the color, yellow color, but this color is appear only slowly. In the solution, potassium iodide solution and potassium iodide solution and lead nitrate solution, here we get an yellow precipitate, that is immediately we get the yellow precipitation. We can be say instantaneously we get the yellow precipitation. But in the case of solid potassium iodide and lead nitrate, we get the yellow color. It is very slowly. These are about the nature and state of the reactant. Next one we can be discuss about the concentration of the reactant. Concentration. What is about the concentration of the reactant? Here, the concentration means that some of the rate of the reaction increases with increase in the concentration of the reactant. If the concentration is increases, the rate of the reaction is also increases. The effect of concentration of the reactant can be explained by only the collision theory. We know about the collision theory. According to this theory, what is about that? The rate of the reaction depends upon the concentration. Otherwise, we can be say the rate of the reaction depends upon the number of collision between the reactant molecules, between the reacting molecule. Here, what is about that? The rate of the reaction depends upon the number of collision between the reacting molecule. Suppose here the higher the concentration, we can be say the greater is the possibility for collision, and hence the rate of the reaction is also increases. This is explains about the concentration of the reactant. Next one is about that this effect of surface area of the reactant. Surface area. Here surface area means increase the surface area of the reactant leads to the more collision per liter per second. Increase the surface area. Surface area is increases. Increase the surface area of the reactant leads to more collision per liter per second. Here, it is one of the heterogeneous reaction. This is not a homogeneous reaction. This is one of the heterogeneous reaction. Here, surface area of the solid reactant play an important role about the reaction rate. Here, a given mass of the reactant, one of the given mass of a reactant, when the particle size is decreases, surface area is increases. Particle size is decreases. Suppose I am taking one of the calcium carbonate. Calcium carbonate is a powdered calcium carbonate, and about that calcium carbonate, another one is a solid calcium carbonate is about the marble piece. We know that one of some of the marble pieces. Am I right? Here, which one have the larger surface area? We know that one. Here, powdered calcium carbonate reacts more than, that is, we are taking powdered calcium carbonate with the hydrochloric acid. Suppose we are taking we are adding some hydrochloric acid. Powdered calcium carbonate reacts more with the hydrochloric acid with a piece of marble calcium carbonate. So surface area of the reactant also play a very important role about in this reaction. For a given mass of the reactant, when particle size is decreases, surface area is also increases. Increase the surface area of the reactant leads to more collision per second. More collision per liter per second. Okay. Increase the surface area of the reactant leads to more collision per liter per second. And also the rate of the reaction is also increases. Here we are taking, how can we explain about that? I am taking two calcium carbonate. One is about that powdered calcium carbonate, and another one is about that mass of calcium carbonate has a marble. That is, both of them are same mass. Both of them are undergoing reacting with hydrochloric acid. That is a dilute hydrochloric acid. Here powdered calcium carbonate react more than piece of marble. Okay. Next, we can be discuss about that effect of presence of a catalyst. Catalyst, what is about the catalyst? Try to understand the concept of catalyst. Here, catalyst, it is a substance which alter the rate of the reaction. Alter the rate of the reaction. That we are saying about that catalyst. It was the catalyst, one of the substance. This is a certain substance, one of the substance. It was explained by about the Berzelius in 1836. 1836, he explained about that catalysis. Here, he identified some of the substance loosen the bond in the reacting molecules and increase the rate of the reaction. Loosen the bond in the reacting molecule and increase the rate of the reaction. But also one more important point, but he also found that substance did not undergo any change chemically. In order to indicate the property, he gave them the name is called as a catalyst. Here in Greek, kata means holy, lein means loosens. There is about the explanation about the catalyst here. Many substances which retard the speed of the reaction. Catalyst is defined as the substance which alter the rate of the chemical reaction. Alter means change the rate of the chemical reaction without itself undergoing any chemical change. A catalyst is defined as the substance which alter the rate of chemical reaction without itself undergoing any chemical change. That one of the phenomenon we can be say about the catalyst. We know that some of the catalyst is about that positive catalyst, negative catalyst, homogeneous catalyst, heterogeneous catalyst, and about that promoters, catalytic poison, auto catalyst, negative, like that we have a lot of catalyst. About what is about the positive catalysis means suppose the rate of the reaction is increasing. The rate of the reaction is increasing by the presence of catalyst. We are saying about that this is a positive catalyst. Rate is increasing. Rate of the reaction is increasing. Suppose the rate of the reaction is decreased by the presence of catalyst. We are saying the negative catalyst. Okay, next about that homogeneous catalysis and heterogeneous catalysis means homogeneous. Homo means same. That means we can be say the reactant, the product, catalyst are in the same phase. Reactant, it may be a solid state. Reactant, product, and also the catalyst are the same phase. That we are saying homogeneous. What is about the heterogeneous means? What is about that? That's a reactant, catalyst, and the product are in different phase. The reactant may be a solid state, but the catalyst may be a liquid state. Like that different state. That we are saying the heterogeneous catalysis. Okay. These are the some examples about that. Next about the promoters. One of the very good examples is about the promoters. Here, in the presence of certain substance, increase the activity of the catalyst. Some of the substance which increase the activity of the catalyst, that are called the promoter. The promoter is not a catalyst. What is the promoter? What is the function of the promoter means? Promoters, one of the substance that promote the, otherwise that increase the activity of the catalyst. For example, the manufacture of ammonia by Haber's process. We know that one, Haber's process, the manufacture of ammonia. Here, manufacture of ammonia means all of you know that one nitrogen combines with the hydrogen, we get ammonia. Am I right? Nitrogen combines with hydrogen to form ammonia. Here we are using one of the catalyst is called as an ion, Fe. Fe acts as a catalyst. Here, the activity of the ion catalyst is increased by the presence of molybdenum. Can you understand? the activity of the iron catalyst is increased by the presence of molybdenum. So, molybdenum is called as a promoters. Okay, molybdenum is called as a what? Promoters. So, that is one about the promoters. Next, about the catalytic poison. What is about the catalytic poison means? When certain substance, when we add it to the catalyst reaction, decreases or completely destroy the activity of the catalyst. When we are adding certain substance, some substance when added to the catalyst reaction decreases or completely destroy the activity of the catalyst. They are called as the catalytic poison. Anyhow, this area we can be thoroughly discussed in another one upcoming lessons. That is, I think that about the surface chemistry, that time we can be discussed thoroughly. Anyhow, what is about the catalyst? That is a very, very important. Here, the substance which alter the rate of the reaction. The catalyst is a substance which alter the rate of the reaction without itself undergoing any permanent chemical change. So anyhow, we can be discussed about the effect of presence of catalyst. The rate of the reaction can be increased to certain extent by increase the concentration, temperature and surface area of the reactant. The rate of the reaction can be increased to certain extent by increasing the concentration, temperature and surface area of the reactant. Here anyhow, a significant change in the reaction can be brought only by the addition of substance called catalyst. So what is about the catalyst? A catalyst is a substance which alter the rate of the reaction, without itself undergoing any permanent chemical change. Here, the catalyst may be participate in the reaction, but again regenerated at the end of the reaction. That is the important point. Here, catalyst may participate in the reaction, but again regenerated at the end of the reaction. The presence of catalyst, the activation energy is lowered. One of the very good important one-word question. Here, in the presence of catalyst, the energy of activation is lowered, and hence the greater number of molecules can cross the energy barrier and change over the products, thereby increase the rate of the reaction. One of the important point. Here the energy of activation is lower, and hence the greater number of molecules can cross the energy barrier and change over the product, thereby increase the rate of the reaction. So these are some important area. We discussed that one. And today I am giving about one of the very good assignment. What is about the assignment means? Try to learn the book back question. Very, very important question. Question number 30. Question number 30 is the assignment. So try to learn this question. Question number 30 is a very, very, very important question. Question number 30. Please all of you write the assignment. Thank you all of you. Thank you. Have a nice day.